In this video, we're going to talk about inequalities. So basically, we have to solve different forms of questions under inequalities to help us understand. Even the most complicated questions that you'd meet, we're going to solve them. Okay, so basically, what are inequalities? So inequalities are going to be equations that may be quadratic functions, may be linear, that you're going to find with these signs. Okay? So that same one I can write it to say maybe less than 0, or I can also put that. So what do these mean? So when you say x squared plus 2x is greater than a 0, so whether it is pointing, it tells you that is something that is bigger. So this part should be greater than 0, then this part should be less than 0. So those are inequalities. So now how do you get to find the values of x that will satisfy the inequalities? That's what we wanted to talk about. So you need to understand that inequalities, for you to solve them, you need to first of all be able to predict or determine the domain of a function. So if you don't know how to do that, watch the video about it. Okay, let's solve the questions. Question 1 is x minus 2 divided by x minus 5. So how do we get to find or solve that inequality? How do we get to find the values of x that are going to make sure that the left hand side is going to be greater than 0? Okay, so first of all, let's try to come up with a domain of such a function. So for the rational function, whenever it is a fraction, the only limitation to our domain is that we don't want our x to be equivalent to we don't want our denominator to be equivalent to a 0. So in this case, our denominator is x minus 5. We don't want it to be equal to 0. That's our goal. So if you make it the subject, you find that you don't want x to be equivalent to 5. So, because whenever you are dividing anything with a 0, it tells you that it's undefined. So we don't want that. Those are the cases that we want to avoid. Okay. The other step that is important when you're dealing with inequalities is to find the critical values when the function may be equivalent to a 0. So when you have a fraction, when you have a rational function, it is only possible to find a 0 when the numerator is equivalent to 0. So in this case, if you look at the numerator, it's x minus 2. So when can it be equal to 0? So if you find the value of x, it's going to be a positive 2. Okay. So for such a question where you only have one critical value, or where your numerator is actually a linear function, you get to use something that is limiting there. Okay? And that. So come up with a number line there. If we draw a number line, we have two values that are going to help us determine the values of x that will make that condition or satisfy that condition. So we have 2 and also 5. So the possible values of x that would define that is either the middle part of these two sides. So let's try it out. So I'll first of all start by getting maybe a value between 2 and 5. So which is basically the easiest one. The smallest one can be, okay, let's get 1. Actually 1 is not between 2 and 5. So let's get maybe a 3. If we get a 3, we plug into the function there at every point where we have our x. So we have 3 minus 2 divided by 3 minus 5. It should be greater than what? 0. So 3 minus 2 is what? It's a 1. 3 minus 5 is what? Is a 2. It's a minus 2. So if you ask yourself a question, is negative 1 over 2 bigger than 0, or it's less than 0? So it being a negative value, it is less than 0. And therefore the condition is not satisfied. So the values between 2 and 5 are not the possible solutions to satisfy that inequality. Okay, let's try values that are greater than 5. We can get maybe 10. So if you plug in 10 there, you have 10 minus 2 over 10 minus 5. So you have 8 over 5. So is 8 over 5 greater than 0? So it's a positive value, so it's greater than 0. And indeed, this is true. It has satisfied our condition there, our inequality. How about the left part? We can also try it out. In most of the cases, when one side has agreed, we expect even the other side to agree. But there may be cases where it's not the case, as you would see in the next question. So Let's try it out. So we can get maybe 1. 1 is less than 2. So if you get a 1, you have 1 minus 2 divided by 1 minus 5. So basically what do we have? So you have negative 1 divided by negative 4, which is going to give us what? 1 over 4. So is 1 over 4 greater than 0? So 1 over 4 is indeed greater than 0. So even that part has satisfied the inequality. Okay, so what are we saying? What are the values of x that are making that to be true? So we've said, first of all, the value is supposed to be from 5 going up. So x should be greater than 5. The first part is we are saying x should be less than 2, but not between 2 and 5. Okay. So how can you present your solution? So the first way that you can express your or present your solution, you can say x is less than 2, x is also greater than 5. Okay, so if the condition, if we add an equivalent sign down there, if it was this part being greater than or equal to 0, so we would have asked ourselves a question, where do we expect that function to be 0? So it's only 0 when the numerator is equivalent to 0. So, and we said when x is actually equal to 2. So we would have added that there to be part of the solution set. But in this case, it's not. So remove it. Okay. So the other way in which you can express or present your solution is you can use set interval notation. So when you say value is less than 2, 2 is the maximum value, then you're going to the negative values, then union, you're starting from 5 all the way up to bigger positive values. So that is the way in which you can present your solution. The next question is a quadratic inequality. Okay. So how do we solve quadratic inequalities? So let's take it as a quadratic function. So we should write it in the actual form, or the basic form in which it is expressed. So it is 2x squared plus 3x. So this can go the other side and to become a negative 14 to be less than 0. Okay, so from there we can now find the critical values where we expect the function to be equal to 0. Okay, so we can try to factorize that. So the product of 2 and negative 14 is minus 28. The sum is a b, which is 3. So what numbers can we deal with there? What numbers can you multiply to give you 28? So what are we looking at there? So we can look at 7 and 4. So it will be minus 4 and 7. 7 by negative 4 is minus 28. 7 plus negative 4 is a 3. So we have 2x squared plus 3x. So where there's 3x, we are going to substitute the factors. So we have 7x minus 4x minus 14. So we're trying to find the critical values where it's going to be equivalent to a 0. So there we have x as our common factor. So we have x plus 7. Then there the factor is minus 2. So we have x. So basically it's coming out to be, there is 2x there. So let me show it. So it's 2x there. 2x. Then even here we're going to have 2x minus 7. Plus 7, sorry. Equal to 0. So we have x minus 2. We have 2x plus 7. So this is after factorizing. So now what are the critical values? What are the values that can make it to be equivalent to 0? So if you get to the first part, x is supposed to be equal to 2. The other part, if you equate that to 0, it's going to be, your x is supposed to be negative 7 over 2. So we found our critical values. So how do we get to find again the values that are going to define the inequality or satisfy it? Okay, so basically there was no need of us trying to look at the domain, because whenever you talk about a quadratic function, it's possible that all the values will define it. Okay, or the set of real numbers. So we have negative 7 over 2 and also 2. So we'll start with the middle part there. Between negative 7 and 2, negative 7 over 2 and 2, the value that is between that can get a 1 or a 0. So I'll go for a 0. So if you plug into the function there, you put in a 0 at every point where we have x. So the first part is going to be cancelled out, the second part will go away, and what we're going to remain with is negative 14. So the question is negative 14 less than 0? Yes, it is. Negative 14 is less than 0. So that tells us that the middle part is satisfying the condition. Let's try out the right hand side, values greater than 2. We can try out a 3. So if you plug in there, you're going to have 2, 3 squared plus 3 by 3 minus 14. So 3 squared at that point is a 9. 9 multiplied by 2 is 18. So we have 18. Then the second part is 3 by 3, which is a 9 minus 14. So basically, we can subtract 18 and the minus 14, we have a 4. 4 plus 9 is 13. So 13 is obviously greater than 0 and not less than 0. So it has refused because it's giving us a value that is greater than 0. But in this case, if you look at this inequality, it is telling us that we're interested in a value that is less than 0. So values greater than 2 have refused. Okay, so we can cancel that part. It has refused. Let's check the values less than negative 7 over 2. So if you divide negative 7 by 2 is something like negative 3.5. So we can get negative 4 to be one of the values that is less than negative 7 over 2. So if you plug in that, get your negative 4 plug in. Where there's x there, what are you going to get? So it will be a 16. 16 by 2, it will be a 32. At that point, it will be 3 by 4 is going to be minus 12 minus 14. So is it less than 0? So if you had 12 plus 14, you have 32 minus 26. So it is going to be what? So it's going to be a difference of 6. So is 6 less than 0? No. So both the left hand side and the right hand side have refused. The only part that is agreeing is values between negative 7 over 2 and 2. So that is our possible solution set. How do you get to present it? So we can say therefore that the values of x that can define that inequality should be from negative 7 over 2, so less than x, and x should be less than 2. So this tells us to say that the minimum value is negative 7 over 2, the maximum is a 2. So if we had an equivalent sign there, would have shown as well, but in this case, no, we don't have it. So using set interval notation, how can you present a solution? So using set interval notation, it can be from negative 7 over 2 all the way up to what? All the way up to 2. Okay, that's how you get to solve quadratic inequalities. So the first question, we've already talked about rational inequality. We've now talked about a quadratic inequality. So we've gone back again to the rational inequalities where you're looking at fractions. So in this case, we're trying to find the values of x that are going to make the left hand side to be less than a 0. Okay, so what did we say? So we said the first thing to note is, first of all, look at the domain. So what values of x can define this function? So the only limitation, or the only thing that limits our domain, is the denominator, because we don't want it to be equivalent to a 0. So we don't want that to be equal to 0. So if you try to find the value of x that will make it a 0, you're going to find that it's going to be actually a root of a negative number, which is a complex number. So it tells us to say that there is no value of x that can make it to be equivalent to 0. There is no way the denominator in this case can be a 0 because of the square that is there, because of the even power, and because it's positive itself. So all the values that we're going to get are going to be positives. Okay, so it's not possible to get a 0 in such a case. So the domain is not limited, so the domain is a set of all real numbers. They are able to define that function. So now, from the domain, what values of x are going to give us a solution that is going to be less than a 0? So we need to look at the critical values. So the critical values, we said, you look at the points or the inputs that can give you a value of 0. So in this case, when is the numerator x cubed going to be equal to 0? So if you find the third root of 0, it's only 0 itself. So the only value that you can put in where there is x on the numerator there to give us a 0 is only 0 itself. So therefore, a critical value in this case, we only have one critical value. Okay. So we have only one critical value because we don't have a limiting input on our denominator part. So it's either the values are greater than 0 or less than 0. One of the two are supposed to satisfy that inequality. So I can get a 1 from our right hand side. So if I get a 1 and I begin plugging in there, so what we're going to have is we have a 1 over the x squared. It's going to be 1 plus 1, which is going to be what? 1 over 2. So is 1 over 2 less than 0? No, it's not. So this part has refused. We go to the other side. Get to plug in the values. We can get maybe a negative 1 as our smallest value. Negative 1 to the third power will be a negative 1. Whenever you raise a negative value to an odd power, it will still be a negative. So we have a negative 1, and we said that the denominator in this case is always going to be a positive value. So the only thing that is determining whether our value is going to be less than 0 or greater than 0 is the numerator. Okay, so down there we're going to have another positive value again. So what has determined is the numerator, because it has got an odd power. Okay, so this is actually true. Negative 1 over 2 is what? Is actually less than 0. Okay, so in this case, our solution, we can say that only the values that are negatives, because if you plug in a negative to an odd power, it will still be a negative, and every negative is less than a 0. And the fact that the denominator is never going to be a negative, so that is true. So only values of x, the only values of x that are going to define this function are supposed to be less than 0. Okay. The next question is looks complicated, but it's not. All you have to do is you have to simplify it before you get to solve it. Okay, so I'll look at my left hand side. I've got a quadratic function there. So there's a possibility that I can find something that can actually cancel out with the denominator there. So let's try to simplify it. Let's try to factorize it. So we have x squared minus 4x minus 21. So there the product that we have is minus 21. The sum that we have is a minus 4. So for the factors, what we have actually, let's try out 7. So remember, our product is negative 21. Our sum is minus 4. So we're looking at 7 and 3. So which one is supposed to be negative for it to be a negative sum? So it's negative 7 and positive 3. These are the two values that can that are the factors to that question. So in terms of factorization, it's going to be x minus 7, x plus what? X plus 3 over what? So again, we'll look at the denominator there. So we want it to cancel out with one of the two. So we can factorize it as well. So we factorize the 3. So we'll remain with what? We'll remain with x plus 3. Okay. Then we'll maintain what's on our right hand side. So for our right hand side, what do we have? So we basically have 4x minus 28 over what? Over x plus 5. So from there we can cancel out something there. Something is going to divide on the left hand side. So what we have now is we have x minus 7 over 3 should be less than 4x minus 28 over what? X plus 5. Okay. So we've simplified it a bit. Let's try to simplify it more. We see where we're getting. Okay. So I'll maintain what's on the left hand side, which is x minus 7 divided by 3. So I'll take this one, the other side, it will become a negative. So we have a negative 4x minus 28 over x plus 5 should be less than 0. So it's now we are taking it almost to the form that we are acquainted to. So we are subtracting fractions. We can come up with a common denominator at that point. Okay. So the common denominator is going to be a product of the denominators that we have. So, and what do we have in this case? We have 3 and x plus 5. So the product is that. So if you divide the 3 into our denominator that we have there, we are going to remain with x plus 5. So we have x minus 7 being multiplied with x plus 5. Then for the other part, we have 3 being multiplied with the numerator there, which is 4x minus 28. So expect that this should be greater than 0. Okay. Let's try to move on. Let's try to move. We see what where we're getting now. So let's try to simplify now. So if you look at that, x multiplied by x is x squared. X multiplied by 5 is 5x. Negative 7 multiplied by x is minus 7x. Minus 7 multiplied by 5 is minus 55. Then what do we have on the other side? So we have 3 multiplying with a minus 4x, which is minus 12x. Then negative 3 multiplying by minus 28. So minus 28 multiplied by 3. 8 by 3 is 24. 3 by 2 is 6 plus 2, 84. So we have minus. So actually we have a negative multiplying by a negative. So we have a positive value. So all that is supposed to be divided by what? We are dividing it by 3x plus 5. This should be greater than 0. Okay, so let's try to simplify it again. Okay, so we look at the like terms now. What like terms do we have? So for the x squared, we only have x squared. Then 5x minus 7x is what? Is minus 2x. Minus 2x minus 12x is going to be minus 14x. So remaining with the constants, 35 subtract from the 84 is what? So 84 minus 35. So 14 minus 5 is what? Is 9. 7 minus 3 is what? It's 4. So we have positive what? 49. Over what? So we have that over 3x plus 5. This should be greater than 0. Okay. We can move on. So we have x squared minus 4x plus 49. So if you look at that, you can also try to factorize it out. So basically the product there is 49. The sum is minus 14. So what values can you multiply to give you 49? You add them, they give you 14. So the possible values are negative 7, negative 7. Okay, so basically that is like equal roots. So it's going to be if x minus 7, x minus 7, which is just x minus 7, x minus 7, divided by 3x plus 5. This should be greater than 0. Okay, so how do you get to solve that inequality? So x minus 7 is the same as what? X minus 7 multiplied by x minus 7 is the same as x minus 7 squared divided by 3x plus 5. Okay, so if you look at this case, if you look at our numerator there, no matter what value you are going to put in, whether it's a negative value, it's a positive value, whatever you are going to put in there, it is still going to be what? It is still going to give you a positive value because it is squared. The fact that it's squared, whether you get a negative value or a positive value, it will still be what? It will still be positive. So the thing that is going to determine what we are going to look at in this case, our possible values, is the denominator. So remember, when you're looking at a fraction, you don't want the denominator to ever be equivalent to a 0. So you want to say your 3x plus 5 should not be equal to 0. So if you divide by 3 there, you remain with x plus 5 should not be equal to 0. Then x should not be equal to negative 5. Because if you plug in negative 5 there on your denominator, it is going to be a 0. So we don't want that. Now, do we have any critical values? Do we have any critical values that are going to make this function to be equivalent to 0? So the critical value that we have is when x is equal to 7. Because we find the critical value by equating the numerator to 0. So there is only one value there. So let's come up with our number line and see how this is going to come out. So we are using the limit, something that is making it undefined, and the possible critical values. So we have our critical value is positive 7, then our limiting value is minus 5, which will make it to be undefined. So we can try out the values between the two. So what values can we try out? So we can get a 0. 0 is between negative 5 and 7. So if you plug into the function there, what are we going to have? So if you put a 0 where there is x, you remain with minus 7. Minus 7 squared is going to be a 49 over, if you put a 0 down there where there is x, it will be 5. 5 plus 5 multiplied by 3 is going to be a 15. So what we have is a positive solution there. So the middle part has agreed. Okay. So how about if you try values after 7? If you try values after 7, the values are still going to be positives. Because if you look at the denominator there, it is positive already. The numerator, remember we say that no matter what value you're going to put in there, the values will still be positive. So obviously we expect that even these values are going to give us values that are going to be positives. Okay. So now let's try out the values less than negative 5. If you try out values less than negative 5, for example, if you get negative 6. So if you plug in where there is x there, it is going to be minus 6 minus 11, which is going to be negative 11 squared divided by what? So if you put negative 6 plus 5, it's going to be a negative 1, which is going to be minus 3. So 11 multiplied by 11 is going to be obviously 121 over what? Minus 3. So if you divide, it's going to be a negative value there, which is making it to be less than 0 and not greater than 0. So the only possible values or only possible solutions that can make this to be true should be between negative 5 and 7 and after 7. 7 itself will make it to be equal to 0. So 7 is not going to be part of the solutions. So therefore, how can you present our solution? So presentation of a solution, what we can say is that our values of x should be between negative 5 up to what? Up to 7. And the values of x should also be greater than 7. So to make this easier, we can use set interval notation to represent it. So we can say that our values of x in this case should be between negative 5 up to 7, where 7 is not part of the solution, and again should be from 7 up to above 7. Okay. So now some of you may be asking questions, why are we not just combining, because 7 is common? So the moment you say that from negative 5 going up, it means that 7 is included and is part of the solution, but in the actual sense 7 is not. Okay, but if it was equivalent to be, let's say, greater than or equal to 0, 7 would have been part of the solution because it would have made it to be a 0. Okay, so we have another question there. How do we get to solve it? Okay, so basically we have to simplify what we have. So if you look at the first part there, our numerator, it's also a quadratic function. So it's possible it has got factors. So what is the product there? The product is minus 12, the sum is minus 1. So what values can you multiply to give you minus 12? You add them, they give you minus 4. So it's obviously a negative 4 and a 3 there. So we have x squared, we have x, I'll get the factors, x minus 4, we also have x plus 3. How about the denominator there? What is our product? So for our product there, what we have is, we have a 21, our sum is 10. So values 3 and 10, 3 and 7. If you multiply them, they give you 21. If you add them, they give you a 10. So we have x plus 3, x plus 7 should be less than 5 over what? Over 4. So at that point, is there anything that can divide? So that can divide. So what you're remaining with now is x minus 4 over what? X plus 7. Okay. So we can take this on the other side, so it will be minus 5 over 4. Should be less than 0. Okay, we can move on. So there we can now, these are fractions that we can add. So we can come up with the common denominator, which is going to be a product of what we have. So we have 4 being multiplied by x plus 7. So if you divide this into that, you are going to remain with a 4. So 4 multiplied by x minus 4. The other part, you divide the 4 into that, you remain with what? X plus 7. So it's minus 5 multiplied by x plus 7. Okay, this should be less than 0. So at that point, 4 by x is 4x minus 16. That is minus 5x. That is minus 35 over what? 4 by x is 4x plus 4 by that is okay, we can just leave it the way it is. So x plus 7 should be less than 0. Okay, let's try to simplify what we have on our numerator there. So 4x minus 5x is a negative x. 16 plus 35 is what? So if you had 16 plus 35, it's going to be a 51. So it's minus 51 over 4x plus 7. This should be less than 0. So how do you get to solve that inequality? Okay, so we are looking at the values that are going to make this inequality to be undefined, and also the ones that are going to define it. Okay, so if you look at x plus 7, we don't want that to be equivalent to 0. That is the only thing that is limiting our domain. So in such a case, x should not be equal to what? Minus 7. Okay. Then, looking at the numerator, we need to find the critical values, the possible values that can give us a 0 in this case. So negative x minus 51 being equal to 0. This is only going to be possible when x is equal to negative 51. Okay. So let's come up with our number line now. So for our number line, we are looking at negative 7 and what? And negative 51. These are the two possible values. These are the values that are going to be help us determine whether what is going to be the possible values of x to define the condition that we have. So between negative 7 and minus 51, what value can we get? We can get a minus 10 as to be values that is going to be easier to work with to simplify. So if you plug in where there is x there, it's going to become positive 10 minus 51 over, so if you plug in where there is x there, 10 minus 10 plus 7 is going to be a minus 3 divided by a minus 12. Okay. So 10 minus 51 is a minus 41 over a minus 12. So that is going to be a positive value, 41 over 12. So is a positive value less than 0, it's greater. So it's basically greater. Okay, so that one I can't satisfy the condition because it's greater. We are interested in the values that are less than. So the middle part has refused. So what values are less than negative 7? So basically, for this was supposed to be actually the number line has actually lost me. Okay, so if you look at that, negative 51 is supposed to be on the left hand side, then you're supposed to have negative 7 on the right hand side, like this. So negative 10 is actually a value that is less than negative 7. Okay, so all the same, the middle part has refused. So we need to try out the values less than negative 51 and the values greater than negative 7. So for the sake of the values that are greater than minus 7, we can get a 1 or even a 0, which will make it easier. So if you get a 0, x will go away. You remain with a minus 51 on top. Even down, the x will go away. You remain with 7 multiplied by 4, which will be a 28. So that is a negative value. So this side has agreed. It has satisfied the condition because the value that we're getting is actually less than a 0. Okay. How about the other side? Let's try it out. So for the sake of the values that are less than minus 51, we can get in terms of tens. So I would advise we go maybe for something closer to 51. Maybe let's go for a minus 60, for example. So if you put a minus 60 there where there is x, what are we going to have? It's going to be a positive 60 minus 51. So for the, remember what we're getting is the value that we're trying is a negative 60. So if you put where there's x there, negative 60 plus 7 is going to be minus 53. So on the denominator part, what we are seeing is we are seeing what? We are seeing a negative value to be the outcome. On the numerator, we have a positive value. So positive divided by negative is going to be what? It's going to be a negative value. So is the negative value less than or greater? It's less than. So even the other part has agreed to be part of the solution set. So it's the values of x that are less than minus 51 and the ones that are greater than minus 7. So in terms of set interval notation, how do you represent that solution set? So you can say that it's from the negative infinity up to minus 51, together from minus 7 up to positive infinity. These are the possible solutions to that condition or that inequality. Okay, how about this one? How would you solve it? How would you solve that question? Okay, so we are dividing two quadratic functions. Yeah? So we can try to factorize what we have. So what basically do we have? So for the numerator, we have the product of minus 3. The sum is minus 2. What are the factors? So for the factors, what numbers can you multiply to give us a minus 3? We had them to give us a negative 2. It's negative 3 and a 1. So we have x minus 3. We also have x plus 1. Over. For the denominator, our product is a 9. The sum is a minus 6. What are the possible factors there? What values can you multiply? So we can multiply a minus 3 being multiplied by a minus 3. So we have x minus 3. We have x minus 3. This should be greater than what? This should be greater than a 0. So that will divide. And basically what you get to remain with is a rational function. So we have x plus 1 over x minus 3. This should be less than 0. So what have we said when you're solving a that inequality? That's basically like the question that we started with. So in summary, to sum it up, or what we're saying is, whenever you have a fraction, find the values that are going to make it undefined, a value that can make it to be undefined. That's for the sake of the linear functions being divided. So in this case, we don't want the denominator to be equal to 0. So it's when x is equal to 3. So put that on our number line. So I can even put it this side. So for the x plus 1, we want it to be equal to 0 so that we find the critical values when the function is equivalent to a 0. So x plus 1 when equal to 0, x is going to be minus 1. So you can put our minus 1 there. We now try out the solution set. So between -1 and 3, what value do we have? It's a 0. So if you put a 0 where is our x there in the equation, you are going to remain with 1 over what? 1 over a minus 3. So that is a negative value. So is a negative value greater than 0? No, it's not. So this part has refused. Get a value bigger than 3, maybe a 4. 4 plus 1 is a 5. 4 minus 3 is a 1. So it's a 5. 5 is greater than 0. So the right hand side has satisfied that inequality. Okay, part of a solution set. Less one, get maybe a minus 2. Negative 2 plus 1 is negative 1. Negative 2 minus 3 is a minus 5. So that will give us 1 over 5, a positive value. So even the left hand side has also agreed. It has satisfied the condition. Okay. Basically, how do you get to present our solution then, in summary of what we've talked about? So we are saying that you can either use just the inequalities themselves, or you can go back to set interval notation. So we can say, okay, so if you look at this side, we are looking at values that are less than -1. So x should be less than -1. Then for this other side, we are looking at values of x that are what? That are greater than that point, 3. Okay, that's one way of presenting your solution set. Now it looks more neatly and better when you use the set interval notation. So if you don't know how to go about set interval notation, watch out our video about that. Okay, so values of x less than -1 go up to the -infinity. Okay, then values greater than 3 will start from 3 all the way up to positive infinity. So that's the way you can present your solution set. Okay, so that's basically the way you get to deal with the inequalities. This video has given you a summary of all the inequalities that you are likely to meet in your exams. Thank you very much for watching.